Minasan konnichiwa, Zamurai Engineer desu. In this video, let us continue our discussion on solutions to simultaneous linear equations by using the Gaussian elimination method. So we already discussed the steps to be taken in doing this method. And in this video, we will particularly look at one of the examples. So let us first explain through example, because it may seem very complex when you are looking at the formula, particularly on the forward elimination. The formula there may look scary, but you can watch and take this lecture 1, 2, 3 times, repeat it until you understood. You will see that the procedure is quite easy. It's like algebraic procedure. So actually, that's correct. And let us formalize our Naïve Gaussian elimination method. Example 1. Given the upward velocity of a rocket at 3 different times, so we have tabulated time versus velocity. So there are two variables, t and v. Therefore, we have here the velocity at times 5 seconds, 8 seconds, and 12 seconds, respectively. The velocity data is approximated by a polynomial as v is equal to a1 t squared plus a2 t plus a3, wherein time is within the domain 5 to 12, including from both 5 and 12. So find the velocity at time 6 seconds. Okay. So the velocity is what? Modeled as, what is this? Algebraic equation, which is a quadratic equation particular. So let us proceed. Assume that v is equal to a1 t squared plus a2 t plus a3. This is actually the given. Is that the given? Velocity data is approximated by. So they probably give us the model. So we are going to look for the value of A1, A2, and A3. And those are, again, the unknowns here, the variables here, because we already have the values for t. Okay, so actually we have t. We would like to know this time we would like to know the coefficient of the equation. So we have 3 equations, 3 unknowns. The unknowns are the coefficient, because tabulated data gives us the time and velocity. So as you can see, using the matrix form and arranging to the format, what, matrix A multiplied by vector variable is equal to vector constant. So that is the format of our explanation on the last video. And you will notice that we arrange T1 squared, T1 and 1. Okay, and then T2 squared, T2 and 1, T3 squared, T3. So there are 3 different values for time. Okay, and correspondingly, there are 3 different corresponding values for velocity for each of the given time. So we'll notice we have the given velocity from the table in the same arrangement. The same arrangement. 106.8, 177.2, 279.2. That is the same arrangement from the table. We can look back to the table. Okay, same arrangement from the table here. Okay, and 5, 8, 12. So therefore we have what? This is 5, 8, 12. So 5, 8, 12. So 5 squared, 55. 8 squared, 64. 5 squared, 44. Because we have this, we can solve the coefficient of the equation, and therefore if we are able to solve the coefficient of the equation, then we have the model. So this problem is actually finding out the model. Okay, so as you can see, okay, find the velocity at t is equal to 6. We don't know. So if we are able to find the model, then it is very easy to substitute t is equal to 6 and then find the velocity corresponding to that. Because that is 6 seconds is within the domain. Okay, so we have the matrix with the corresponding values for time and velocity. So let us therefore do the Gaussian elimination. So first forward elimination, then afterwards we will have the backward substitution. So this is the Naïve Gaussian method. Okay. So just to simplify further, this is another technique of further simplifying. Just remember that your variable is A1, A2, A2. So what happened here? We just what? We just separate them by dotted lines. They separated them by dotted lines. This is the what? The square matrix. So this is the square matrix A. This is the variable vector and constant vector. So we have the constant vector. We do not need to use the variable vector. Anyway, later on, it will come up. Okay. So just writing it down this way will shorten up our writing, particularly if the matrix is more than 3 by 3. Okay. So let's go to the forward elimination. First step, forward. Number of steps of forward elimination. So because we have n is equal to 3, so n minus 1 is equal to 2. So there are 2 steps. So excuse me. There are 2 steps for our forward elimination. And that is, we start with the elimination of this one. We have to eliminate this one. Okay, meaning we want this to be 0. And also this one and this one. That is our first target. And by doing that, we want to do that. If we want to do that, we need what? We want to do that, we need to manipulate equation 1 by dividing this line by 25 because we want this to be 1. So divide by 25 is 1. Divide by, we will not change the first line, but we need it to be manipulated because we want this to be used to eliminate this one. So if this become 1 by dividing by 25 and then multiply by 64, then equation 1 will have the value 64 as coefficient for the first term, So this is first term, second term, third term. Okay, so we need that. So by dividing by 25 and multiplying by 64, this is equal to 2.56. So multiply all of this by 2.56. So it will become 64. It will become 5 times 2.56, that is 12.8. And then this one, 1 times 2.56. And then 106.8 times 2.56 is 270.4. Okay. So that is how we operate to be able to make this 0. So this is our equation 1 actually. This is our equation 1 transformed so that the first coefficient is equal to this. That is necessary because we would like this equation 1 to be subtracted from equation 2. So look, equation 2, 64, 8, 1, and 1772. This is equation 2. So equation 1, put it below that so that we can easily subtract. So subtract 64 minus 64, 0. 8 minus 12.8, negative. 1 minus 2.2 is negative. 177.2 minus is negative. Okay? Verify this is correct. This should be correct. Okay? This is greater. So it is also negative. Okay, so 208. So 3 minus 7, that is 6. So this is 6. This is 9. Okay, so negative 96.208. So this is the correct. Updated. This is the updated equation for number 2, equation 2. So replace this one by this one. Okay, substitute new equation for equation because this is now the updated equation. Now let us do the same for the third equation so that this one will become 0 or eliminated. So let us do that. Okay, by what? By using again the first equation. Again, use the first equation, multiply it by 144 and divide by 25. You can interchange divide and multiply, but the principle says that we first divide by 25 because that is the coefficient of the first term. So divide by 25, multiply by 144. Divide, multiply. Very easy. Divide, multiply. And then 144 divided by 25, that is 5 point something. Okay. 5.76. Okay. So multiply all of this by that. What is this? This is equation 1. Equation 1 multiplied by this 5.76 here, it will become 144, 28.8. But let us take this one by one. Multiply this equation 1. Look, this is the equation 1. And then 5.76, this is the 144 divided by 25. Okay. So 25 multiplied by 5.76, that is 144. 5 times 5.76, this is 28.8. 1 times 5.76, of course, 5.76. 106.8 times 5.76, this is 615.168. So this is now our equation 1. This is our equation 1. And this should be subtracted from equation 3. So our equation 3, write it down here. This is our equation 3. Write it down here. And then subtract this one. Okay, subtract. Therefore, 144 minus 144, 0. 12 minus 28.8 is 16.8. And 1 minus 5.76 is 4.76. Those are negative. And lastly, we have 279 minus 2. 279.2 minus 615.168. This is negative 335.96. Use your calculator to verify this. Using your calculator. Okay. So we now have the updated equation 3. This is our updated equation 3. Okay. So when we have updated equation 3, so replace our equation 3. So you will notice this is our updated matrix. We call this as extended matrix because this is our basic matrix with the constant values, right? This is the constant vector. This is the constant vector. The constant vector plus the square matrix. This is our extended matrix. Okay. So the next procedure is to eliminate this one so that it will become what? Upper triangular matrix. Okay. So we need 0, 0, and 0. So this one will be retained. Okay. Triangle. Upper triangular. Okay. So we have one. Okay. This is our updated. And then therefore we need this one. We need equation 2 because this is the one we need to. So we don't need equation 1 anymore because it is already used to make these 2 zeros. 1, 2. If you use this one to make this 0, you will not succeed because this one will become 0, but this one will become a constant value, not equal to 0. So that's the reason why we need to use this second equation, because if we use 0 minus 0, it will still be 0. Unlike if you use the first equation, if you subtract this to this, it will become negative 25. For example, okay? So that's why we need to use the second equation now. So second equation, therefore, divide by this number and multiply by this number. So negative 48, negative 4.8 multiply by negative 16.8. So negative 16.8, then negative 4.8. That is 3.5. So if you do that, therefore, let us multiply the second equation by that, by 3.5. So This is negative 4.8. This one. Multiply by 3.5. That is negative 16.8. And negative 1.56. Multiply by 3.5. That is negative 5.46. Okay. And negative 96.208 times 3.5, that is negative 336.728. Okay. Therefore, if we subtract this equation 2, this is our equation 2, manipulated equation 2, subtract it from equation 3. So take note of equation 3 here. This is our equation 3. Take note, 335.968. Okay. So subtract this equation 2 from that equation 3. So we'll have 0, 0. We now have 2 zeros here. And then this one, negative 4.76 minus 5.46, that is 0.7. Positive because this is greater. Negative minus, so negative, negative, that's positive. Okay. And if you subtract this one, there is a typo error here. This is not positive 335. This is negative 335. Take note. There is a typo error here. Take note. Negative, negative, negative. Negative, negative, negative. This is negative. They are all negative. So negative, because if you made this typo error, your answer will be wrong because positive 335 minus will become plus. So 335 plus 336. That's a very big number. Okay? Very big number. But if this is negative, negative, negative plus, it will become subtraction. Okay? So this is positive, this is negative. So this will become what? Subtraction. So this is 16, so 7.76. So 0.7. So this is our third equation. So put it on our extended matrix. So 0.7, 0.76, 0.7%. Okay? So this is now our completion of the forward elimination. Okay? We are through with forward elimination, then let us now go to the next phase, which is backward substitution or back substitution. So 0.7, this is again wrong. This is 0.76. 0.7 and 0.76. That is a typo error. Huh? 0.7 and 0.76 here. Okay. Again, typo error here. This means that this is A subscript 3, A3 is equal to 0.76. So this is 0.7, this is the coefficient, A3 is equal to 0.76. Therefore, 0.76 divided by 0.7, this is 1.08571. Okay, that is the value of A3. We know the value of A3. And since the second equation here, there are only two variables, A2 and A3. Here, there is only one variable, A3. So we are able to solve. Here we have two variables, A2 and A3. But A3, we already know the answer. So substitute this one to the value of A3 and multiply by this coefficient, and then we can solve for A2. let's do that. We already know the value of A3. So let's go to A2. So A3, substitute the value, multiply by negative 1.56, and then put to the other side, that will become positive. So 1.56 positive, and then divide both sides by negative 4.8. Divide both sides by negative 4. So this is our simplification. So simplifying by, and simplify, okay, simplify, and by doing that, do not be confused because it is very easy. Negative 4.8, put it down. That is coefficient of A2 because this is variable A1, A2, A3. Yeah, A1, A2, A3. A1, A2, A3. So this is for A2. So put negative 4.8, A2, negative 1.56, A3 is equal to negative 96.208. So just put it there and then simplify. Put this term to the other side, it will become positive. So negative 96208, negative 96.208 plus 1.5683. Then divide both sides by negative 4.8 because that is the coefficient of this. So A2 therefore is negative 96.208 plus 1.56 times 1.08571. What is this? This is the value of A3 that we already solved in the previous page here. 1.08571. Okay, 1.08571 divided by negative 4.8. Therefore, A2 is equal to 19.6905. Okay. So if you got that, we can now substitute that A2, A3 to be able to solve A1. So let's do that. Okay, just put all the coefficients 25, A1, 5, A2, 1, A3, then equals to 106.8. Okay, that is our equation. Therefore, put these two to the other side, it will become negative, negative, negative 5, A2, negative A3. Then divide both sides by 25 because this is the coefficient. Divide by 25. And therefore, substitute the values that we already saw in the previous page for A2 and A3. So divide by 25 here, and then you have the answer. We are able to solve A1, A2, and 3. Okay, so therefore, we can have the following. This is our solution for this matrix. Okay, so the variable vector A is equal to, this is our answer for A1, A2, and A3. Okay. Solution vector. That is our solution vector. The polynomial that passes through the 3 data points, then we can now put it up on our equation. So this is our equation, quadratic equation. We have now the proper coefficient for A1, A2, A3. Quadratic equation because the highest exponent is 2, t squared. Okay. So therefore, since we already have this equation, just substitute the value of time, which is 6 seconds, we can solve for the velocity at that time. Okay, so that is what? Coefficient A1, 0.290472 times 6 squared plus 19.6905 times 6 plus 1.08571. If you use your calculator, the answer is 129.686. meter per second. So this is our answer. Okay, I think this is the last slide. Last slide, and please rewatch, review, review repeatedly until you find out. So look for, make another random given values for you to solve. And also there are, you can find so many problem solving given in the book that we are using. So use our book and then look for problems, then try to solve with this type of procedure. Use this procedure. Don't choose other procedure. Not yet. We are not going to other procedure yet. There are many procedures. There are many techniques. We are just using this one. Okay? So try to follow this solution method. Okay. So therefore, please use your comment section for your question, suggestion, and inquiry. Anyway, again, this is Dr. DrEYPEI, Preaching Engineering Foundation.